Welcome to Math Mystico. Today we are going to start a new series in which we will discuss about various areas related to circle. You all are familiar with a circle. It has a radius, a diameter, a circumference and area. Apart from this, we also have other regions inside a circle like segment of a circle or sector of a circle. So do you want to learn how to find the various areas? In this session, we will discuss mainly about area of a circle and area of ring. Let us quickly discuss the various area related formulae. If the length of the radius of a circle is denoted by r, then the length of the circle, which is also known as circumference of the circle, is given by c equal to 2 pi r. And the area enclosed by this circular region is given by a equal to pi r square. And when we have two concentric circles as shown in the figure, then we come up with the concept of ring. This area between the two circles is the area of the ring. If we denote the radius of the inner circle by small r and the outer one by capital R, then the thickness of this ring is given by capital R minus r. How would you calculate the area of this ring? Yes, the green portion is the area of the smaller circle. If we remove it from the larger circle, we get the area of the ring. Therefore, the area of the ring would be pi capital R square minus pi small r square. If we take pi common, we are left with r square minus r square. If you want, you can further simplify this calculation by using the algebraic identity a square minus b square equal to a plus b into a minus b. And hence we have this new formula. Talking about some other situations, we can also have a circle inside a circle touching one another but not having the same center. So if R1 and R2 are the radii of the outer and inner circles respectively, then the distance between the two centers A and B will be given by the difference R1 minus R2. In another similar situation, the circles could be touching each other but not lying inside one another as shown in this figure. In this case, the distance between the centers will be given by the sum of the radii, that is R1 plus R2. Now let us talk about the application of these formulae. In the first situation, we are given that the circumference of a circle is equal to the circumferences of the two given circles, whose radii are 19 and 9 centimeters respectively. We may name the radii as R1 equal to 19 centimeter and R2 equal to 9 centimeter. And let the radius of the required circle be R. You may solve this problem by finding the circumferences of the two circles separately and then adding and putting it equal to the circumference of the bigger circle. But I have an easier method of doing it that will save your time as well as energy. How? Simply write down the given relationship in algebraic form. So we can denote the circumferences of the two given circles as C1 and C2 and that of the new circle as C. According to this statement, C is equal to C1 plus C2. Using the formula C is equal to 2 pi r, the circumference of the first circle is 2 pi r, second is 2 pi r1 and third is 2 pi r2. If you carefully observe this equation, we have 2 pi multiplied with each term here. So we can simplify it further by dividing each term by 2 pi and we get r equal to r1 plus r2. It's 19 plus 9 equal to 28 centimeter. Wasn't it easier? So try this method in other questions also. Let's try this problem now. Let the radii be denoted by R1 equal to 8 centimeter and R2 equal to 6 centimeter and R be the required radius. As the statement here says that the area of the required circle is sum of the other two areas, so we get the equation A is equal to A1 plus A2. Replacing by the formula of area, pi r square is equal to pi r1 square plus pi r2 square. Again, there is something common which is multiplied throughout. Right, it's pi. So let's divide this equation throughout by pi, and we have r square equal to r1 square plus r2 square. Substituting the values given to us, we have 8 square plus 6 square, which is 64 plus 36. This means r square is equal to 100, and so r will be square root of 100, that is 10 centimeters. So you can observe this method is much simpler as compared to finding the areas one by one, adding them, and then finding r. Now this target board is made up of concentric circles. The diameter of the innermost circle is given 21 centimeter, and the radii of the concentric circles increases by 10.5 centimeter. There are 5 parts in this board. The first one is a circle of golden color, and rest of them are rings. We have to find their area one by one. Let's start with the golden area. As diameter is 21 centimeter, its radius r1 will be 21 upon 2 centimeters. So area is a1 equal to pi r1 square. You know we take pi equal to 22 upon 7 normally. So 22 upon 7 into 21 upon 2 into 21 upon 2. Cancelling the various factors and multiplying the remaining, we get 693 upon 2, which is equal to 346.5 centimeters square. Next, the radius of the red region R2 is given by R1, that is 10.5, plus the width 10.5, that is equal to 21 centimeter. As it is a ring, its area will be given by area of red circle minus area of golden circle, that is pi inside brackets r2 square minus r1 square, which as I discussed earlier can be simplified as r2 plus r1 into r2 minus r1. Replace all the values and simplify it. So we get 22 upon 7 into 31.5 into 10.5. Now another tip you can follow to make the calculations easier. As 105 is divisible by 7, I will remove the decimal of 10.5, cancelling and multiplying all the numerators. I get 10395 and 1 decimal from the denominator 10. So we have 1039.5 centimeters square. The remaining 3 parts are also rings, and I hope you can solve it yourself. So try it yourself. I will share the answers with you, and if any step is not clear, you can ask me in the comment box. You all are familiar with a situation where a wheel of a car is moving. How much distance does a wheel cover in one revolution? Yes, it covers a distance equal to its circumference. So in the next question, you can find out the distance covered in one revolution by the wheel whose diameter is given, and then you have to find out the total number of revolutions made by the wheel in 10 minutes. Radius of the wheel will be 80 upon 2, that is 40 centimeter. Let's find out the distance covered in one revolution. It is 2 pi r, that is 2 into 22 over 7 into 40. On simplifying, which is 44 into 40 upon 7. Another tip for you, we will not solve this further because that will only waste our time. This is not a part of the answer we are required to give, so we can use it in the same form. Now the speed of the wheel is given in kilometers per hour, whereas the distance we are using is in centimeters and the time given is in minutes. So we need to change this into centimeters per minute. 1 kilometer has 1000 meters. So we'll multiply by 1000, and 1 meter is 100 centimeter. So further by 100, and 1 hour has 60 minutes. Cancelling and simplifying further, we get the speed in centimeters per minute. Now we are asked to find the number of revolutions in 10 minutes. So let us first find the distance covered in 10 minutes, which will be this into 10. Number of revolutions is equal to total distance covered upon distance covered in one revolution. So it will be 110000 upon this. Now as it is a fraction, its numerator will come in the denominator, 44 into 40, and the denominator 7 will go up and multiply in the numerator. So let's cancel the various terms which can be cancelled, and multiplying the remaining numbers, we get the number of revolutions is 4375. Clear? Now let's try another example. Here we are given that area of the circle is equal to its perimeter, and we have to find out the radius. So let us take the radius as r. The statement says area equal to perimeter. So replacing by the formulae, we get the equation pi r square equal to 2 pi r. As we have to find r here, we can bring all the r terms to the left hand side and take other terms to the right hand side. So r square upon r equal to 2 pi upon pi. Pi will cancel. R square upon r is equal to r. So we get r is equal to 2. As the units are not given, we can just write units here. In the next example, we have a pond and a circular path all around it, and we are asked to find the cost of constructing the path. Let's quickly show a figure to explain this answer. We'll get a ring shape where the inner circle represents the pond. The radius of the pond is 17.5 upon 2. That is 8.75 meters. Let us denote it by small r. The width of the path is 2 meters. Let us denote the outer radius by capital R. And therefore the radius of the outer circle will be the sum of inner radius and the width of the path, that is 8.75 plus 2 equal to 10.75 meters. The area of the path will be the area of the ring. So it is pi into capital R square minus small r square. Putting the values, 22 over 7 into 10.75 plus 8.75 into 10.75 minus 8.75, using the identity a square minus b square equal to a plus b into a minus b. Simplifying further, we get area of path 122.46 meters square. That we know the area, we can find the cost of construction. Rate of constructing is given rupees 25 per meter square. Therefore, the cost of constructing the path will be 25 into 122.46, which comes out to be rupees 3061.50. So this was all for today. I hope you have enjoyed this session. We'll meet again in the next session, where we will discuss about areas of sectors and segments, for which you can click on this link. If you like my videos, please subscribe and like, and keep watching. Stay safe. Goodbye.